All right. This is question 17 from 7-2. This is one of the best homework questions of the entire year. At this point, you should probably start to realize how much you are learning in this class. It says, give the most descriptive name to the figure formed by connecting the midpoints of each of the following figures. The key of this problem is remembering or going back and relearning, if you never learned in the first place, the properties of the diagonals of these figures. First of all, we've already proved twice that if you connect the midpoints of any quadrilateral, what is the resultant shape? A parallelogram. So you could have put a parallelogram for all of these. It just would not be the most descriptive name. So for a rhombus, how are those sides related? They're all congruent. What kind of relationship do the diagonals have? They're perpendicular bisectors of each other. That's key. Okay? So, when you draw the midpoints, when you connect these two, how are these pink segments related to the pink diagonal? Due to the midline theorem. They are parallel to the pink diagonal, and they are half of the pink diagonal. Now, how do these red segments that I'm drawing relate to the red diagonal? They're parallel to the red diagonal and half the measure. So since the pink diagonal is perpendicular to the red diagonal, and the pink line is parallel to the pink line, red line parallel to the red line, how is this pink segment related to this red segment? They're perpendicular, which makes that shape a rectangle. Did you get that right? Okay. So on B, it's a kite. Lily, would you mind hitting the lights for me? I don't need that big of a kite. That's a ridiculous sized kite. Okay. Diagonals of a kite. How are they related? One is the perpendicular bisector of the other. Okay? So, again, if we took the midpoints of this side, the midpoints of this side, and we connected them, for the same reasons as before, since the diagonals are perpendicular, then we know these are perpendicular, and therefore that is a rectangle. And again, this is all due to the midline theorem. And the midline theorem involves what kind of shapes? Triangles. So if I could just kind of cut this out and show you, review to you the midline theorem. There we have a triangle. If we take the midpoints of two of the sides of the triangle and connect them, we form a red line here. How is that red line related to the blue line if it's the midline? It is parallel to the blue line, and it is half of the blue line. I can't say this enough. It's like the key. All right, so now let's think about a square. How are the diagonals of a square related to each other? They are, oh, that is not an acceptable square. I get on these drive-through confessionals and I get so nervous to be on the internet. One more time. How are they related? Congruent and perpendicular. Right? So, if I connect these, What am I going to have? Another square. So why was this one a square and the other ones were rectangles? Because in a square, the diagonals are also, they're not only perpendicular, but they're also congruent. So if we said this was half of the red diagonal, and this was half of the red diagonal, then you know that they're equal to each other. What about a rectangle? How? How are the diagonals of a rectangle related to each other? Are they perpendicular? They are not. Are they congruent? They are. So since the diagonals are congruent, but not necessarily perpendicular, then you know that this shape formed by connecting them is a rhombus. And you'll recognize this as the Argyle pattern, if you guys are into fashion. You know what I'm talking about? Anyone know about it on sweaters and socks? Okay, that's the Argyle pattern. What about a p-gram? I'll make room for this one over here. If I draw it, I got to make sure when I draw the parallelogram that I make sure it's not a rhombus, or else we might make the wrong deductions about our diagonals. Are the diagonals congruent to each other? They are not. Are they perpendicular to each other? They are not. So the only thing we know about this pink shape that I'm forming is that what is it? It's a p-gram. Okay? A quadrilateral, I don't even have to draw the picture. I shouldn't, I don't think. What is it? It's a p-gram. Now, are you good enough to do this one without the picture? Isosceles trapezoid. Anyone got an answer? Bryson? It is a rhombus. Awesome. Because the diagonals are congruent, but they're not necessarily perpendicular. So now I'll draw it. We got two congruent sides here. We got two parallel sides here. That makes this an isosceles trapezoid. These are the exact same lengths. We could prove that with with congruent triangles, which makes this blue. So these lines are congruent, and they're equal to half the measure of this diagonal. But these lines are equal to half the measure of this diagonal. But the diagonals are congruent to each other, so that is a rhombus. Awesome question. Okay. Lily, you got a question about that? Okay. Anyone else have a question about this particular one? Liv? Why is... Okay. That fact has now been proven for you twice. You've done it on your homework. The first time we did it was last chapter. We did it in a coordinate proof. And remember, I did it with random letters. It's also on Drive-Thru Confessionals, last chapter, I think. Okay? The easiest way I could show you is if I draw any... That's not a line. Let's use my line tool. If I draw any random quadrilateral, I want to just... That's not a trapezoid or a kite. It's close to both, but... Come on. Alright, Liv. Now, first thing you got to do, and again, this was a proof. We just proved this. In chapter 7.1. What is going on with the Interite board today? Alright, I think I'm probably running out of batteries. No, that's my fault. Okay. So what I want you to do, Liv, is consider those diagonals and think about the triangles that they've formed. So this blue diagonal has formed a left triangle and a right triangle. If I take the midpoint of this side and the midpoint of this side, and I connect those with a blue line, that is now a midsegment. Do you know the properties of the midsegment? That's right, very good. So this segment AB is half of OH. Okay? And it's parallel to it. Does that make sense? Well, if I look at this side of it now, bless you, you got it now? And if I draw that, that segment, GU, is parallel to and half the measure of OH. So now we know that thing has to be a p-gram. Does that make sense? Pretty cool, huh? All right. Any other questions on that? Let me save it.